So yesterday we talked about trig ratios. We started trig ratios, sine, cosine, and tangent. And then we got into solving for missing sides. So on page 9, I asked y'all to work on that before you left yesterday. So I'm going to go through those really quick. So first thing you have to do is you have to identify the angle you're looking at and then identify or label the sides. So if I'm looking at angle 31, x would be opposite, 11 would be hypotenuse, the blank side would be adjacent, but we don't need that one because it's blank. So if I have O and H out of my three trig ratios, which are SO, chi, and TOA, the only one with O and H is sine, so I'd use that. And I'd have sine of 31 equals my opposite x over adjacent 11. Multiply both sides by 11, and you get x equals 5.7. Everybody get that? Okay. Number 2, you have angle 44. X would be your adjacent side. 85 would be hypotenuse. The only one with A and H would be cosine. So I'm going to have cosine of 44 equals adjacent x over hypotenuse 85. Multiply both sides by 85. And you have x equals 61.1. So if I have A and H, I have to use cosine. So I'll have cosine of 56 equals adjacent 6 over hypotenuse x. So now your x is on the bottom instead of the top of the fraction. Therefore, you can't just easily multiply both sides, but you can use the trick that you just switch the x and the cosine function. So I'd have x equals 6 over cosine 56. Now plug that in the calculator and you should get x equals 10.7. Instead of working them out, I'm just going to write their answers. So I have x equals 128.4 on number 5. X equals 20.4 on number 6. X equals 24.5 on number 7. And x equals 87.5 on number 8. Okay, so those are just some they're pretty basic ones of how to solve for sides. They can get more complicated. There are word problems in this unit, and there are some that have two triangles involved in them. And we're going to see some of those on page 11. But let's go ahead, look at page 10. So on number 1 on page 10, it gives you that triangle and it wants you to find the ratios with that triangle. In order to do that though, you have to have all three sides. I'm missing a side. I'm missing side PQ. If I'm missing a side on a right triangle, I can use the Pythagorean theorem to solve for that side. So I'm going to use the Pythagorean theorem to solve for that missing side. So when I do that, QR is my hypotenuse, and then the other two sides are my A and my B. So I'm going to have x squared plus 14 squared equals 50 squared. So side squared plus side squared equals hypotenuse squared. Then I can subtract 14 squared from both sides. And I'd have x squared equals 2,304. And what is the square root of 2,304? 48. So that side right here is 48. So now I can use my trig ratios to solve for sine, cosine, and tangent of angle Q. So 50 would be your hypotenuse, 14 would be the opposite, and 48 would be the adjacent. So sine is opposite over hypotenuse. So I'd have 14 over 50, and that reduces to 7 over 25. Cosine would be adjacent over hypotenuse. So 48 over 50, and that reduces to 24 over 25. And then tangent opposite over adjacent, so 14 over 48, and that reduces to 7 over 24. So yesterday, we talked about how if we find the sine of one acute, sine, cosine, and tangent of one acute angle, we can use those to find sine, cosine, and tangent of the other acute complementary angle. So, what would sine of R equal based off of what we just did for Q? Which one of those three does sine of R equal?
Cosine.
Cosine of Q. So sine of R is 24 over 25. What's cosine of R? 7 over 25. And then tangent is the reciprocal. So I'd have 24 over 7. So switch and flip. If you can't remember that, you can always go back in and do it like regular. You'd have R right here. Hypotenuse stayed the same. This will become opposite. That would be adjacent. And you can set them up again. But the switch and flip is just the shortcut to that. Okay, so on number 2, we're just going to do a few of these on the front. I think I'm only going to go through the evens, maybe. We'll see. Go through the evens and I'll give you the answers to the odds. So on number 2, 48 is our angle. 17 would be adjacent. X would be opposite. So opposite and adjacent, we're going to use tangent. So I'd have tangent of angle 48 equals my opposite x over my adjacent 17. So when you put that in the calculator, when you multiply 17 on both sides, what do you get for x? 18.9. Our angle is 29. 12 would be our opposite. X will be the hypotenuse. So we have opposite and hypotenuse. We're going to use sine. So we have sine of 29 equals opposite 12 over hypotenuse x. So now since we have an x on the bottom, we can't just easily multiply in one step. We have to switch their places. So I'm going to switch the sine function and the x. So I have x equals 12 over sine of 29. And that should give you 24.8. On number 5, you should get 35.6. So now I have x on the bottom, got to switch them again. So I have x equals 22 over tangent of 58. So on number 6, you get 13.7. Number 7, you get 18.5. And then on number 8, we've got hypotenuse and adjacent, so we're looking at cosine. So cosine of 37 equals adjacent 48 over hypotenuse x. Since x is on the bottom, gotta switch the place of the cosine and the x, so I'd have x equals 48 over cosine 37. So what did you get for x on number 8? 60.1. Yeah. And then on number 9, you would have to use sine, and you get x equals 3.7. So, same thing on the next 2 problems. So, on 10 and 11, I'm not going to go over those because I feel like we've done enough of those for now anyways. So, on number 10, you have to use tangent, and you should get x equals 20.5. And then on the next one, you have to use sine, and you get x equals 13.8.
I would not know.
Okay. So on number 12, it wants you to find DC. This is one of those where it's got 2 triangles and you have to find 2 different things. So in order to find DC on this right triangle right here, we have to have another side. So the only side that touches the other triangle would be this one right here. So I'm going to solve for x first. So I'm going to solve for that side. So just looking at that little right triangle, I need to solve for x. So here's my angle. X would be opposite. 20 would be hypotenuse. So I use sine. So sine of angle 54 equals my opposite x over hypotenuse 20. So then I'll multiply both sides by 20.
16.2.
When I put that in the calculator, you should get 16.2 for this side. So now I'm going to call what I'm looking for the DC y. Okay, so I have 16.2 on this side. I need to find this one, and this angle is 28. So, got that angle 28, y would be my adjacent, 16.2 would be opposite. So I have to use tangent. So tangent of angle 28 equals opposite 16.2 over adjacent y. So since y is on the bottom, got to switch the tangent and the y. So I have y equals 16.2 over tangent 28. Then I can solve for y by putting it in the calculator. When you plug it in, you should get 30.5.
Are you
So,
always gonna do the tangent and
what?
are you always gonna do? Never mind.
So to solve for x, I'm going to multiply 14 on both sides. And 14 times tangent 51 gives me x is 17.3. This side's 17.3. So now I can solve for y, looking at 17.3 and y and the angle 72. Y would be adjacent, and 17.3, would that be opposite or hypotenuse? Hypotenuse. So I've got adjacent and hypotenuse, so that means I'm going to use cosine. So I have cosine of angle 72 equals my adjacent y over hypotenuse 17.3. So what would I need to do with that 17.3?
You have to multiply by both
Multiply it on both sides. I have 17.3 times cosine of 72. And what does that give you?
5.3.
5.3. So KL is 5.3. Based off these word problems, we are going to draw a picture and then we're going to solve. So it says a wire attached from the top of a 30-foot telephone pole to a stake in the ground. So if the angle formed by the wire and the pole is 48 degrees, what is the length of the wire? So first off, it tells us we have a 30-foot pole, right? So I know I have a 30-foot pole. It really just says 30 telephone pole, but it meant 30 feet. So it tells me that there's a wire going to the ground from the top of the pole. So it forms a right triangle. So this would be the wire. That would be the pole. And that would be the ground.
Oh, I did it right.
So it says that the wire and the pole form a 48-degree angle. So the angle between the wire and the pole is 48 degrees. And then it wants you to find the length of the wire. So the wire side, which is the hypotenuse, would be x. So with that, we can now set up a trig ratio. First, we got to figure out which one we need. So we're going to label the sides. So looking at our angle right here, 48, x would be the hypotenuse, and 30 would be the adjacent. So when I have a and h, I'm going to use cosine. So I have cosine of my angle 48 equals my opposite, or not opposite, adjacent 30 over hypotenuse x. Since x is on the bottom, I'm going to switch the place of the cosine and the x. I have x equals 30 over cosine 48. And what does that give? 44.8. So 44.8. And we'll just assume it's feet because it didn't say. We'll assume it's feet. So it says that an airplane climbs at an angle of 12 degrees with the ground, finds the horizontal distance it has traveled once it reaches an altitude of 500 feet. Okay, so what you got to think here is here's the ground, right? Then we have an airplane that's taking off from this point. We're going to say it's taking off from there. So it's going to take off. It's gradually going to rise, right? That's how an airplane does. So we want to know how far it has to travel to get to a vertical height of 500 feet. So
I bet
this,
the horizontal.
yeah, it wants to know the horizontal distance that it takes to get to a vertical height of 500 feet. That's what altitude is vertical height. So the hypotenuse is the plane's travel. The travel of the plane. This would be your horizontal distance. The ground would be. And then this would be your altitude of 500. So we need to know that horizontal distance at the bottom. First, we've got to figure out where to put the angle though, because I haven't put the angle anywhere. It says the angle with the ground and the airplane as it climbs. So the bottom and the hypotenuse will be where angle 12 is. So now we have everything we need to solve this problem. The hardest part with word problems is setting up the picture. The rest of it is just like what we normally do. So if I have my angle is 12, what is x? Opposite, adjacent, or hypotenuse? Adjacent, and 500 would be opposite. So I have opposite and adjacent, so I'm going to use tangent. The tangent of angle 12 equals my opposite 500 over my adjacent x. Then since x is on the bottom, gotta switch the place of the tangent and the x. So I'd have x equals 500 over tangent 12. That should give you 2,352.3. To start with finding missing angles of right triangles. First, you need to know in a right triangle, if you have two sides, in any right triangle, if you have two sides, you can solve for either of the acute angles. Because you already know one of the angles is 90, so you can solve for any of the other two. So first thing you have to do is just like the others, so label the sides based on what angle you're looking for. Then based off of that, you're going to find your trig ratio that you're going to use. And then you set up an equation. So first three steps are just like what we were just doing. But now you have to use the inverse trig ratio. Did you not find your bracket column? Okay, so what the inverse, so what the inverse of a trig ratio is basically to undo a trig ratio, you take the inverse, which would be like cosine, raised to the -1. Okay? Cosine to the -1 cancels out cosine. Sine to the -1 cancels out sine. And tangent to the -1 cancels out tangent. So those are called cosine inverse, sine inverse, and tangent inverse. That's what the little -1 is. So cosine inverse, tangent inverse, sine inverse. Those three things undo the functions. And as we talked about yesterday a little bit, theta is a variable for an angle, and it's the little zero with a line through it. So that's what we use for an angle most of the time, is a theta. So, for an example of what this looks like. Looking at number 1, this is our angle we're looking at. Alright, so we identify our angle. Now we need to label the sides based off of that angle. So based off that angle, 7 is what? Opposite, and 10 is hypotenuse. So we labeled our sides. Now what trig ratio will we use? SOHCAHTOA or TOA? So. And then we set that up exactly like we did yesterday and earlier today. So sine of our angle, which is theta, just a 0 with a line through it equals opposite 7 over hypotenuse 10. So now to get rid of that sign, you have to do something to the sign to make it go away. What you do to one side, you have to do to the other. So what we're going to do is we are going to sign inverse both sides. So I'm sign inversing both sides. So what that sign inverse does is it cancels that sign right there so that we will have just the theta equals sine inverse of 7 over 10. And to put that in your calculator, you're going to hit second sine.
Is it 44.4?
Yeah. So we will round to 1 decimal place. So you're going to hit green key sine 7 divided by 10, and you should get theta equals 44.4 degrees. Okay. Number 2 has an X for its angle, which is fine. It can be either theta, X, it can be whatever variable. You can have any variable for an angle. It can be theta, it can be X, it can be whatever. But on number 2, our variable for our angle is X. So we're looking at this angle, and we need to label the sides based off that angle. So 4, is that adjacent, opposite, or hypotenuse?
Adjacent.
8, opposite or hypotenuse?
Opposite.
So what ratio am I going to use? Sine, cosine, or tangent? Tangent, because we got TOA. So I'll have tangent of angle X equals my opposite 8 over my adjacent 4. So when I tan inverse both sides, the tangent would go away, and I'd have tangent inverse of what's 8 divided by 4? 2. So I could just put tangent inverse of 2 in the calculator. So if you don't want to write the little tan inverse on both sides like I did on the first one, that's fine. If you can remember to do it. But you'll do tan inverse of 2, and what does that give you? 63.4 degrees. Okay. Number 3, got our angle. So we've got our opposite is 9 adjacent is 7. So I'm gonna use tangent again. So tangent of angle X equals opposite 9 over adjacent 7. Tan inverse both sides. And you just have X equals tangent inverse of 9 over 7. And what do you get when you do tangent inverse of 9 over 7? 52.1 degrees. Then number 4, got our angle theta. 5 would be our adjacent. 12 would be our hypotenuse. So which trig function are we using? Sine, cosine, or tangent? Cosine. We gotta use A over H, so cosine. So cosine of theta equals adjacent 5 over hypotenuse 12. If you get rid of cosine, to get the theta alone, you'll cosine inverse both sides. You'll have theta equals cosine inverse of 5 over 12. What's that give you?
Like 6.
6 on 5.4.